Now in today's chemistry class we will study about physical property of amine. So let's start it. So now about physical property of amine. Now let's restart. It is observed that in a case of primary amine, as the number of carbon atom increase in primary amine, its melting point and boiling point will increase. So we can write it in a case of primary amine, as number of carbon atom increase, it is observed that its melting point as well as boiling point, melting point and boiling point is going to increase. So in a case of primary amine, as the number of carbon atom increase, its molecular mass will also increase, contact surface area also increase, and due to this van der Waals force of attraction will also increase. And as a result, in a case of primary amine, as the number of carbon atom increase, its melting point and boiling point will also increase. So we can say that the melting point and boiling point of methane amine as compared to methane amine, ethane amine having a higher melting point and boiling point as compared to ethane amine, 3 carbon containing propane amine having a higher melting point and boiling point. Methane amine boiling point is 280 Kelvin, ethane amine is 298 Kelvin, and propane amine having a boiling point is 322 Kelvin. Now it is observed that the melting point and boiling point of amine is higher than corresponding alkane amine. So we can write that the boiling point of amine is higher than corresponding alkane amine. It will be higher as compared to their corresponding alkane. Now why the melting point and boiling point of amine is higher as compared to corresponding alkane amine or alkane? Then it is observed that in alkane there is a carbon hydrogen bond. So this carbon hydrogen bond is observed that it is a non-polar in nature. While in amine compound there is a nitrogen-hydrogen bond. So nitrogen having a partially negative charge and hydrogen having a partially positive charge. So this nitrogen-hydrogen bond of amine is polar, and due to this it is observed that in a liquid state of amine, intermolecular attraction will be more in a case of amine as compared to alkane. Therefore, suppose we have taken 2 carbon containing ethane amine, then its melting point and boiling point is higher as compared to 2 carbon containing ethane. Now third thing, it is observed that the melting point and boiling point of amine is lower as compared to alcohol. We can write it amine boiling point is lower, or we can say less than corresponding alcohol. The reason is quite easy or simple. When we take this amine compound, then it is observed that in amine compound there is a nitrogen-hydrogen bond. So nitrogen having a partially negative charge and hydrogen having a partially positive charge. We have written that this bond is a polar. But in alcohol there is an oxygen-hydrogen bond is there, and electronegativity of oxygen is more as compared to nitrogen. Therefore this oxygen-hydrogen bond is comparatively more polar. Now this oxygen-hydrogen bond in alcohol is more polar. So in a case of alcohol, intermolecular attraction will be more as compared to amine. So because of this bond is more polar, so we can write that in alcohol, in a case of alcohol, intermolecular attraction will be more. And when intermolecular attraction is more, then we can write that due to this more intermolecular attractions, then more boiling point. The amount of energy required to break this bond will be high. So when we compare this 2 carbon containing ethane, then after ethane amine and ethanol, then ethanol having a boiling point 351 Kelvin, while ethanamine having a 290 Kelvin. Boiling point of ethane is just only 184 Kelvin. So we can say that the boiling point of amine is higher than that of alkane but lower than that of alcohol, and reason is intermolecular attractions. Reason is the polarity of bond. In alcohol, oxygen hydrogen bond is most polar, while in amine this nitrogen hydrogen bond is comparatively less polar, while this carbon hydrogen bond comparatively non-polar. So when polarity of bond will increase, the intermolecular attraction, van der Waals force of attraction will be more, and therefore boiling point will be more. And due to this, ethanol boiling point is higher as compared to ethanamine boiling point is higher as compared to ethane. Then after, it is observed that in isomeric alkyl amine, as we go from primary to secondary and secondary to tertiary, its melting point and boiling point will decrease. So you know very well what is meant by isomeric alkyl amine. In a case of isomeric alkyl amine. Now isomeric alkyl amine means amine having the same molecular formula but structure will be different. Suppose in isomeric amine we have taken 3 carbon. As we go from primary amine to secondary amine or secondary amine to tertiary amine, we can write that their boiling point is constantly decreasing. Now why this boiling point of primary to secondary and secondary to tertiary decrease? Then as a branch increase, as we go from primary to secondary and secondary to tertiary, branch increase, intermolecular distance will increase, and therefore intermolecular attraction will going to decrease. So when we take this propane amine, CH3, CH2, NH2 propane amine, then this propane amine is primary amine and it has a boiling point. We have written that it is at 322 Kelvin. Now we take this next methyl ethyl amine. It is a secondary amine, and next amine is tertiary amine. We are taking a trimethyl amine. Now you can observe that this all amine having a same molecular formula, and same molecular formula of all this amine is carbon 3, hydrogen 9, and nitrogen is just only 1. Secondary amine having a boiling point just comparatively 309 Kelvin, and this trimethylamine having a boiling point 276 Kelvin. So it is observed that in a case of isomeric alkyl amine, as we go from primary to secondary and secondary to tertiary, the boiling point are going to decrease. It is observed that in primary amine, contact surface area will be more as compared to secondary amine, and as compared to secondary amine, in tertiary amine, contact surface area will be less, intermolecular distance is going to increase. And when intermolecular distance is going to increase, it is observed that intermolecular attraction is going to decrease. And due to this reason, in isomeric alkyl amine, as we go from primary to secondary and secondary to tertiary amine, their boiling point is constantly decreasing. Now, one more reason we can give for boiling point of primary, secondary and tertiary amine. It is observed that in primary amine, in a case of primary amine, this formula of primary amine, we know that it is RNH2. So in a liquid state of primary amine, each molecule of amine is joined with to another molecule with a weak intermolecular hydrogen bond. So now here hydrogen having a partially positive charge and nitrogen having a partially negative charge. So in a case of primary amine, each molecule of amine have a form 2 hydrogen bond, and due to this formation of 2 hydrogen bond, it has a comparatively higher intermolecular attractions. So in a liquid state of amine, the number of hydrogen bond formed by primary amine is almost double as compared to secondary amine. Now this positively charged hydrogen having an attraction for negatively charged nitrogen. So each molecule joined with 2 molecules of uh, amine, and due to this it has a hydrogen bonding. And because of this hydrogen bonding, the primary amine having a number of hydrogen bond is comparatively double as compared to secondary amine. Now when we have taken this secondary amine, then secondary amine molecule having a just only one hydrogen, and because of it has a one hydrogen, it is observed that it can form only one hydrogen bond. So hydrogen having a partially positive charge and nitrogen having a partially negatively charged. And because of this, it has a hydrogen bond. So it is observed that in a case of secondary amine, it has a formula R2NH. Now it has a formula R2NH, so it has just only one hydrogen, and because of this only one hydrogen, it can form only one hydrogen bond. So number of hydrogen bond formed by primary amine is almost double as compared to secondary amine. And due to this, we can say that primary amine having a higher boiling point as compared to secondary amine. Now, sixth physical property of amine compound is amine compound are soluble in water. It is observed that in a case of primary amine, nitrogen having a 2 hydrogen, and therefore it has a tendency to form a 2 hydrogen bond with water molecule. We can say that it has a tendency to form 2 hydrogen bond with a water molecule. Now in a case of secondary amine, this nitrogen having a 1 hydrogen bond, and because of it has a just only 1 hydrogen bond, it has a tendency, it has a 1 hydrogen atom, and because of this 1 hydrogen atom, it form only 1 hydrogen bond with water molecule. So this primary amine and secondary amine form hydrogen bond with water molecule. It has a tendency to form hydrogen bond, and they are able to form hydrogen bond. Therefore, primary and secondary amine compound are soluble in water. This hydrogen bond we can give in this way, that here water molecule, this each molecule of amine is connected with the 2 molecules of water. This oxygen having a partially negative charge and hydrogen having a partially positive charge. So each molecule of amine, primary amine, can join with a 2 molecule of water through a hydrogen bond. Now it has a hydrogen bond with 2 water molecule, and because of this they are soluble in water. But solubility of primary amine is higher as compared to secondary amine, and reason is the number of hydrogen bond formed. Now in secondary amine, this nitrogen having a just only 1 hydrogen, therefore it can form hydrogen bond with only 1 molecule. So here the number of hydrogen bond formed by primary amine is double as compared to secondary amine, and therefore primary amine compound are more soluble as compared to secondary amine. So in this part we have studied 6 physical property of amine. We have studied that in a case of primary amine, as the number of carbon atom increase, their melting point and boiling point are going to increase due to increase in a molecular weight. Second property, we have observed that melting point and boiling point of primary amine is higher as compared to corresponding hydrocarbon. Third property, we have seen that in a case of primary amine or in a case of isomeric alkyl amine, as we go from primary to secondary and secondary to tertiary amine, intermolecular distance is going to increase, and therefore melting point and boiling point are decreased. Fourth property, we have studied that in a case of primary amine, nitrogen having a 2 hydrogen atom, and because of this it will form 2 hydrogen bond with other amine molecule. So as we go from primary to secondary, secondary amine nitrogen having just only 1 hydrogen, and it can form only 1 hydrogen bond in their liquid state. So primary amine having a highest hydrogen bond and highest boiling point, while tertiary amine having a less intermolecular attraction, less hydrogen bond and lowest boiling point. It is observed that primary amine molecule form hydrogen bond with a water molecule, as well as secondary amine also form. But the number of hydrogen bond formed by primary amine is almost double as compared to secondary amine, and therefore melting point and boiling point of primary amine is higher, solubility is also higher. Thank you very much for watching my video. Please share and subscribe my channel. Thank you.